Hey guys, this is the very last video of the 40S pre-cal course for my grade 12s. This is the second half of the lesson I started in my last video on the binomial theorem, and this is kind of just working backwards from what we did in the first video. And remember that we just learned a new formula for the expansion of a binomial. It's t to the k plus 1 is equal to n choose k times a to the n minus k times b to the k, and that of course is given that you're expanding a binomial that's in the form a plus b to the n, and k just happens to be the nth term, so t sub n is also the same as t to the k plus 1. Oh, I'm writing off the screen. There we go. Okay, so find the term that contains x to the power of 4. So notice this is backwards. The last example, we would have taken a question like this and said, expand it and tell us what the fourth term is. Well, this time we're working backwards. We don't know what it is. Is it the fourth term, fifth term, sixth term, ninth term? But somewhere there's a term that has an x to the 4 in it, and I want to know which term that is. Okay, let's look at what we know in this example. We know that a is x squared. We know that b is negative 2 over x. And remember that negative belongs to the 2 because we have to think of this as a plus b. So that's where that negative has to exist. And we actually know that n is 11. And we're looking for, let's see, well, we're looking for the term that's going to be t sub n. We kind of want to know what k is, really. So what we're going to do here is we're going to find out which one has the x to the 4 as a variable. And what it says here is very interesting. It says the numerical coefficient does not make a difference. Because think about this. This choose formula gives you a coefficient, and the b term has a 2 in it, so it'll give you a coefficient, and then those two numbers would multiply to make what goes in front, but none of that has any effect on what happens to the variable. Notice that for the variable, the x to the 4 term, or the term that has x to the 4 in it, comes from basically just this part of the equation. So I don't really even need that part. I'll need it later if I want to figure out what that term is, because I'll have to figure out the coefficient. But to actually figure out which term it is, I really don't even care about the coefficient. So all I care about is that a is x squared, and then that's n minus k, and then b is, of course, in this case, 1 over x. Now again, you're going, well, wait a minute, it's 2 over x. Yeah, but I don't care about, actually it's negative 2 over x. But I don't care about that negative 2. It doesn't matter. Coefficients don't matter. All I care about is, and let me just, I didn't give myself a lot of room to work here, so I'm just going to move up to here. So notice that this is going to turn out to be x to the 4, and I know n is 11. So that's x to the 2 to the power of 11 minus k. And I can rewrite 1 over x actually as x to the negative 1, and that's to the power of k. And my job is to figure out what k is. Well, I can simplify this using my exponent rules, right? Power of a power means that you multiply them, so that's 22 minus 2k. And then negative 1 times k is negative k. And then when you're multiplying powers that have the same base, you can, of course, add the exponents and make that 1 power. Right? And when you add negative k, that's just like minusing k. So x to the 4 is actually equal to x to the 22 minus 3k. Remember this from the exponent unit? If I have this equation here, I can just do what any good DJ does and drop the base and just write an exponent equation. Oops. Right? If some number to this power equals some number to that power, and it's the same number, the two powers must equal each other. And I can make an equation out of that. So 22 equals negative 3k. 4 equals 22 minus 3k. I'm going to minus the 22 from both sides. Divide both sides by negative 3. And k is equal to 6. So if k is equal to 6, this equation there I just did, gave me a 6. So that means t sub k plus 1 is equal to t sub 6 plus 1, which is equal to t to the 7th. Therefore, it is the 7th term. Okay. Now, I'm going to do something I don't usually do. I'm going to actually just get another scrap page here for the notes, because go to scrap paper, and there we go. I'm going to actually figure out, well, what is this seventh term? And this, of course, now just harkens back to what we did in the last part of the lesson, right? I use my formula, t to the k plus 1 is equal to n choose k times a to the n minus k, b to the k. And let's make sure we know what we know, right? We're looking for the seventh term, so that means k is equal to 6. We know that n was equal to 11, right? N was 11. And then a was x squared, and b was negative 2 over x. So I just use my formula. So the seventh term is 11 choose 6, right? Because again, k is 6, times a, which is x squared to the power of 11 minus 6. b is negative 2 over x, and that's to the power of k, which is 6. And so my seventh term is 11 choose 6, which I don't know what 11 choose 6 is. I'm going to have to punch buttons on that. 11 choose 6, 462, and then times x to the, now 11 minus 6 is 5, 2 times 5 is 10, and then negative 2 to the power of 6. Okay, I do know that 2 to the 6 is 64, and the power on a negative that's even will make it just 64. So times 64 over x to the 6. I don't know why I put an extra bracket there. This is why I never write in pen. And so to make that into a simplified answer, it's 462 times 64. I don't know what that is. Sweet. 29,568. And x to the 10 divided by x to the 6 is x to the 4. And yes, that was what we wanted, right? We wanted the term with the x to the power 4. Now the question actually only asked us find the term. So there we go, we found the term. But we actually did have to find out first that it was the seventh term. Cool. So this part, this is the only way to do that, unless again you really wanted to expand this and figure out what the seventh term is after you multiplied 11 of them together, in which case you might be a psychopath and you'd frighten us all. There is, however, another way to figure out that this was the seventh term. I find this more work and more tedious, but some students really like doing it this way, and it's just by purely finding a pattern. Remember how the exponents work. In the first term, you would take the x squared and the 1 over x. And again, coefficients don't matter when I'm just trying to figure out which term it is. So you would take the x squared to the power of 11, and then you take the b, which is 1 over x, to the power of 0. Remember how this pattern works? And then in the second term, this number goes down 1. And in the third term, this number goes down 1. And on this one, it goes up 1. Remember that? The pattern for a is that the exponents decrease, and the pattern for b is that the exponents increase. So I just have to kind of think about what that is. So this is x to the 22, right? And then, of course, that's just 1. Then this one would be x to the 20 times 1 over x, which is x to the 19. This one is x to the 18 in the first bracket times 1 over x squared, which would be x to the 16. And then I look at these numbers, 22, 19, and 16, and I notice that they're always going down by 3. Yes, they will always make a linear pattern. So I could actually just kind of count it. I could say, well, the first term has to be x to the 22. The second term has to be x to the 19. The third term has to be x to the 16. And then just keep literally counting down by 3. So the fourth term would be x to the 13. My fifth term would be x to the 10. My sixth term would be x to the 7. And my seventh term would be x to the 4. And ding, 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 I wanted the term that had x to the 4 in it, so I stop x to the 7. Some people do it this method even more sophisticatedly. They actually realize, oh, if I have a linear pattern, I can actually turn that into a linear equation. I can say that the term number, my first term, second term, third term, I just found out, have exponents. Now, I don't want to use x for exponent or e. I'll use p for power. The first term had a power of 22, the second one had a power of 19, and the third one had a power of 16. And then use y equals mx plus b. Use linear algebra. You could say then that y equals mx plus b. And those are easy things to find, right? This is the slope, which, you know, it's always going down 3, so that's negative 3. And remember, the y-intercept happens when your x-coordinate's 0. So just count up. If you count up 3, that's 25. So there we go. That formula will tell me that the term that I want that has a power of 4 would be move the 25 to the other side and then divide both sides by negative 3, and you get that it's the 7th term. So there's multiple ways to find the 7th term. I still kind of like the way I did it here. I like algebra. I'm an algebra fan. But this is kind of cute. Finding a linear pattern out of it is I think, more work. But if it makes more sense to you, then you're better at that than you are at algebra. By all means, I wouldn't stop you from doing it that way. Okay, so that was example 1. Let's do another one. Example 2 is determine the constant in the coefficient. Or sorry, let me say that again. Blech. Determine the constant in the binomial expansion of that. So, excuse me. What is the constant? Well, first of all, think about what a constant is. A constant is a term without a variable, meaning that it is p to the power of 0, right? Because think about it, p to the power of 0 is 1. And every number in the universe except for 0 to the power of 0 is 1. And p can't be 0, because if p was 0, 1 divided by 0, this thing wouldn't exist. So I know for a fact that p to the 0 is 1. I also know, let's gather our information here. I know that n is 18. I know that a is 3p. I know that b, can you guess what it is? I'll give you a sec to guess. Correct. It's negative 1 over p. And now, notice again that I don't really care about coefficients when I'm just figuring out what term it is. So for my purposes of figuring out which number it is, to find k, right? To find k, really, I can use an a that's just p. I don't care about the coefficient of 3. And I can use a b of just 1 over p. I don't care about that negative 1. Or, better yet, p to the negative 1. So, using, again, the formula, let's just write the formula down like a million times so that we never forget it. And choose k, a to the n minus k, b to the k. I really don't care about this part, so I'm just using that part, right? The p to the 0 will be p, right? The a term, which is, I'm just using p, to the n minus k, which is n is 18 minus k, times, and b is just 1 over p to the k. And again, I could have just, I already wrote that over here. I don't know why I didn't write it there. So that's 18 minus k, p to the negative 1 to the k. There we go. That's shorter. I should have done that in the first step. Okay, so that means p to the 0 is equal to p to the 18 minus k times p to the negative k, negative 1 times k. Then in the next step, I can add those exponents together. So that's p to the, those two things add, so that's 18 minus k minus another k, which is 18 minus 2k. Once again, DJ, drop the base. Don't need it anymore. I know that 0 equals 18 minus 2k as a formula. So 2k is equal to 18, so k is equal to 9. So therefore, k is equal to 9. T sub n is equal to t sub k plus 1. So we are looking for the 10th term. Okay, so now that I'm looking for the 10th term, we can use this formula fully. But remember, now that we're dealing with coefficients again, we got to put the coefficients back. So now I got to go back to these givens and actually put the coefficients back on a and b. So t sub 10 is equal to 18 choose 9, right? Because that's n, and remember that's k, which is 1 less than n, times a to the power of 18 minus 9. Sorry, I got to write so small. I don't have a whole lot of room here. Times b to the power of 9. Okay, let's plug in a and b now. So that's 18 choose 9. A, remember, is 3p, so that's 3p to the 18 minus 9 is 9. And b is negative 1 over p, so negative 1 over p to the power of 9. Now remember, this was supposed to be the term without a constant, and I can see that that's about to this was supposed to be the constant, which is the term without a variable, and I can see that that's about to happen, because this is going to be p to the 9, and this is going to be 1 over p to the 9. Then p to the 9 is going to cancel, which is exactly what we wanted. So I'm going to have to punch 18, choose 9. It's going to be something big. Actually, I already did this. It's 48,620. Lovely. And this is then 3p to the 9. 3 to the 9 is 19,683, so that's p to the 9. And then that's negative 1 over p to the 9. Remember that a negative to an odd power is still a negative. So those p to the 9s cancel, and my 10th term is a jumble constant of negative, and these two numbers times together, I actually did this calculation already to save time. It is, let's see, 460 is the last three digits, then 987, and then 956. And I have a friend who teaches in the North End in Kelvin High School, and he says, you know what I always want to do with questions like this on a test or an exam is, for an extra mark, could you write that number in words? I bet a lot of you haven't read a big number like that since they made you do it in elementary. Could you do it? That is 956,987,460. And you'd lose that half mark if you put ands in the middle of that. You can't say and in the middle of a word because that means decimal. Anyway, notice we got what we wanted. A constant. It was a big constant, but it's a constant nevertheless. Okay, one more little example. Determine the value of n if the fifth term in the binomial expansion of this is that. So I know it's the fifth term this time. I would like to know what the exponent was. This is different. Okay, so once again, to determine n, we don't need to worry about the coefficients. Why not? Because they don't really have anything to do with how this power behaves when it comes to the variable. So for a equals 2x squared, I just use a equals x squared. And for the b, which is negative 1 over x, I just use b is equal to 1 over x. I don't have to worry about that negative. Okay? But I do have to worry about making this a power, and that is a negative power. So x squared, which is right here, and again the 280 doesn't matter, who cares about the 280, x squared is equal to, and again I'm basically just using this part of the formula, right? So that's a, which is x squared, to the n minus k. Well, I don't know n, but I do know, hang on, if it's the fifth term, right, then what do I know about the fifth term? If it's the fifth term, then k is 1 less than n. K is 4. So this is n minus 4. And then that would be times, and then the b, I have to use x to the negative 1, the power that's already on x. And, oh, I lost my squared. Sorry, there we go. So, yeah, a is x squared, so that's x squared to the power of n minus 4. b is x to the negative 1, so that's x to the negative 1 to the power of 4. So x squared is equal to x to the 2 times n minus 4, which is 2n minus 8, and negative 1 times 4, which is negative 4. And now make that one equation, or one single factor, by adding the exponents. 2n minus 8 minus 4 is 2n minus 12. And now I have an equation where I can get rid of the base. Add 12 to both sides. Divide both sides by 2. And there we go. The exponent here was a 7. Cool. You can now do the 8.3 part 2 worksheet. And that's it, guys. That is the last lesson we're going to do course-wise. Now, because of the whole COVID thing, we did skip a whole chapter and a couple of parts of another chapter, of 2 other chapters. So I am going to post links to the videos that the school has already made for those units. And I'll also post links to where you can download the notes packages for those units. And if you want to spend some time over the summer catching up on the parts of the course that you kind of got gypped out of because of this whole lockdown, shutdown, quarantine thing, you can do that. You know, it'll put you at the same footing and on equal playing ground with the people you're going to have to compete with in your first year math courses who had the full math course because they took it in semester 1. From the start, this has always been very unfair to you guys. I know it's like, oh, we have to work so hard at home. Yeah, but the guys who worked first semester had to work harder and faster, but they got the advantage of seeing the entire course and you didn't. So that's about the only other thing I'm going to post on the blog. How about I leave you with my favorite graph? You know, this is the only graph you're ever going to need. I even call this the all-you-need graph because, like John, Paul, George, and Ringo taught us 50 years ago now, all you need is that. Have a great summer, everybody.